This time we'll be looking at Theorem 1 of circle geometries in grade 11. But first I want us to look at the two definitions that may be of help as we progress with our theorem. As I mentioned in the previous video to say that I will add a few definitions as we move along. So those definitions are theorem and axiom. So what is a theorem? So a theorem is a statement that can be demonstrated to be true by accepted mathematical operations and arguments. All right. We'll look into that as we prove the first theorem that we'll be doing today. All right. So an axiom. What is an axiom? So an axiom is a rule or statement that is accepted as true without proof. All right. We can state out few examples from this. If you still remember that in any right angle triangle, so suppose this is our right angle triangle. Yes, suppose this is our right angle triangle, and we have the points A, B, C, and we can call that R, and call that X, and call that Y. But we can use the small letters A, B, and C like that. So in any right angle triangle, we have learned that AC squared is equals to AB squared plus BC squared. Then if we use the small letters, then to be R squared is equals to X squared plus Y squared, which now reminds us of the theorem of Pythagoras, which applies in a right angle triangle. So this is the theorem of Pythagoras. So that is one statement that is accepted to be true. We don't have to prove it. But also be advised, as you move to grade 12, you also learn how to prove the theorem of Pythagoras using the similarity or equiangular theorem. All right, so that's one theorem statement that is accepted to be true, the theorem of Pythagoras. Number two is another theorem which says the line from center, or rather we can say the radius is perpendicular to the tangent at the point of contact. So the radius and tangent, they form a 90-degree angle at the point of contact. But we'll talk about that as we do the theorem that involves tangents. All right. Okay. Now let's look at the first theorem. The first theorem says that a line drawn from the center of the circle perpendicular to the chord bisects the chord. So there must be a line from the center of the circle, and that line at the point of contact must then form a 90-degree angle with the chord. As that happens, that line must then divide the chord into two equal halves. Cool. All right, so we're looking at that. So as you see OM is the line from center, and this line as we draw it from the center, it forms a 90-degree angle. And according to the theorem, it says if the line is from the center and is perpendicular to the chord, it must bisect the chord. So perpendicular means forming a 90-degree angle at the point of contact, and bisect means cut in half, or divide the chord equally. So it cuts the chord in half. So with that, we can also say, okay, there is our OM being the line from the center perpendicular to the chord bisects the chord. So if a line from center is perpendicular to the chord, that means then it divides the chord into equal parts. Then AM must then be equals to MB. So with that, we can say if the statement, if the line OM is perpendicular to AB, we can then say AM is equals to MB, right? So if OM is perpendicular to AB, then AM is equals to MB. That's what the theorem is saying there. So let us look at how to prove the theorem now. How to prove the theorem. So what will be given and what is required of you to prove? So let me just enlarge this one. All right, let me just give you the given information. So we're given a center or a circle. So we're given O is the center of the circle, with OM perpendicular to AB. Then prove the theorem that states that AM is equals to MB. So prove the theorem that says AM is equals to MB. So with that, we're going to say so for every proof that we need to do, we need to have construction. So construction. So with the construction, what are we going to construct? Okay, that's fine. So what are we going to construct? I'm going to construct radii. So draw a radii or radii OA and OB. As we do this, you realize there are two triangles that are formed. Okay, by just looking at this radii, these are we just having equal. Remember, we mentioned and under our definitions, or to say that radii is just a plural form of many radius. So, and we said radii are equal in a given circle. So any line that is drawn from center to any part of a circumference is equidistant. So they are equal distances. That is radii. So all radii are equal. So again, we are seeing that there's a common line OM there. So somehow this triggers the thought of congruency. So for us to prove that AM is equals to MB, then congruency kicks in. So because already we can see that, okay, OM is there, OB and OA are radii, and OM is a common side, and OM is perpendicular. That also informs us that congruency can be used to prove the theorem. So with that, let's say in triangle um, MOA and triangle BOM. I'm just writing them like this, but as we prove congruency, the order is very important. But now let's look at, so in these two triangles, OA is equals to OB. You remember what is mentioned here. OA is equals to OB, so radii. That will be our reason there. Radii means that, as we know that a radii in a given circle are equal. And again, we are seeing a common line. OM is a common side between the two triangles. And thirdly, we see that they told us that OM is perpendicular to AB. That means there's a formation of 90 degree. We can then also conclude that here we also have a 90-degree angle. Then we can say angles in a straight line. But because they told us that OM is perpendicular to AB, AM1 is also 90 degrees. So we would say that one angle M1 is equals to angle M2. Both of these angles are equals to 90 degrees. This is a given information. We are given that it's a given information, but we can also add to say we are given that OM is perpendicular to what? To AB. We are given. This is given information. All right. What do you notice now? We have OM being equals to OB, a side. OM is a common side, and M1 and M2 are equal, so that is an angle. But look at the type of angle that we have here. It is a right angled. Let me just use a different color. It is a right angle. So this is a right angle. So we, so we can now conclude to say the two triangles, let me just write it as AOM. It must be congruent to triangle. Now, look at how I wrote it at the end there, but doesn't matter for the first triangle. I can write it as MOA and maybe rearrange the letters again. All right. The second triangle that I'm going to write, it has to follow the order of the letters that I've written there. So with that, let us see. Angle A. We don't know much about angle A, right? But we know that OM is a common side. And again, okay, let's just start here. Look at OA and OB. So we started with the first two letters, AO. So we must also start with the first two letters there, as it is shown. So it has to be BO. So the line AO must be equals to line BO, as indicated, radii. And again, we have the line OM, which must be equals to line OM, is a common side. So that means the order of our letters will then be like that. Look at M1 and M2. So the last letter there is angle, it's M, and in both true triangles. So that means angle M is equals to angle M. So if we are concluding that the two triangles are congruent, that means they are exactly the same. They are identical with angles and sides. So that means angle A is the same as angle B, angle O is equals to angle O, angle M is equals to angle M, according to the two triangles. Thereafter, AO is equals to BO, OM is equals to OM. Therefore, we can say AM is BM, but not the car, of course. So, all right. So I would say this is since we have the right angle, you remember? So we can use the letter R to represent right angle, followed by, in a given right angle, the hypotenuse is a side that is opposite the 90-degree angle. So it is the right angle and our hypotenuse, which is our radii, in each triangle there. So, and we have a common side that we have proved to be R, a common side. That's why we say R for the right angle, and H for the hypotenuse, and S for a common side that we have proven there. But also, we are not limited to this. Note that, but let me not use it for now. We'll use it at some other time, because, let's not worry about that. So then, from this, we are saying that the two triangles are exactly the same. So since they are exactly the same, we'll then say, oh, AM must then be equals to what? To MB. AM must be equals to what? MB. You see that? So if the two lines or part of a lines are equal, we then say, why did we say these are equal? Because we took this from our proven congruency of the two triangle. So it's AOM congruent to triangle what? BOM. So we have proved that the two triangles are congruent. Therefore, AM is equals to MB. So that means you have proven the theorem by saying by doing that. Then in conclusion, if you just want to add, remember the theorem said that the line from center perpendicular to the chord bisects the chord. We can then conclude and say, oh, indeed, OM bisects AB. It does really cut it in half, but otherwise you are done from this stage. But if you want to shine, yeah. So with that, we are done proving the theorem, and this is one of the formal theorems that one needs to know for exam purposes. All right. So now let us look at an example where we do some calculations as we use the axiom that I've illustrated before. Okay. So let's look at this one now. So this example says O is the center of the circle, OM perpendicular to AB. So O is the center of the circle, OM is perpendicular to AB. And the length of OM is 5 centimeter and OM is 3 centimeter. Then we are required to calculate the length of AB. All right. So let's see, what are we given again? Let's change the colors there. And this one back to green. So we are given OA 5 centimeter. So again, it is important that we also understand the lines that we are given here. So what is OA? We must understand it's a line from the center to the circumference. So a line from the center to the circumference is our radius. And you must understand that all radii are equal in a given circle. So even if I construct another radius here, if I construct another radius here, it must have the same magnitude, right? So, but we don't need it for now. So let's look at this. And they said the line OM is 3. So there is 3. They told us OM is perpendicular to AB. Then we would agree that this one will also be what? A 90-degree angle, because OM is perpendicular to AB. So now, what type of a triangle are we having here? We are having a right-angled triangle. So in a right-angled triangle, if we know two sides, then we can use the theorem of Pythagoras to find AM. Remember that axiom we spoke about. So according to the theorem of Pythagoras, it says that OA squared is equals to OM squared plus AM squared. So if that is that, we need to provide reasons now. So the reason here is Pythagoras. So, or you can write theorem of Pythagoras. So let's now replace our values there. So OA is 5. Then you square that, which is equals to what is OM? It is 3 centimeters. Then square that plus AM squared. So now we get 25 here. 5 squared is 25. Then 3 squared, it is 9 plus AM squared. Then now take the 9 over the equal sign. That will give us 25 minus 9. 25 minus 9, that will give us that is 16, right? So that will give us 16. So AM squared, so AM squared is equals to 16. Then apply square root both sides. And remember, we are dealing with length. So length is always a positive value. So we can put plus or minus there. Therefore, we conclude that AM is positive 4 centimeters. Remember that distance is a positive. Is positive. So we don't have a negative distance. All right. Then we calculated our AM. But that was us looking for AB. So we managed to get a part of it. How do we get the other part? Now, if we recall from the theorem that we just proved or learned just now, we learned that the line from the center, and if the line from center is perpendicular to the chord, it must then bisect the chord. So we would say that AM is equals to MB. If you still remember that, AM is equals to MB. Why is that so? The reason that we must then provide, we say this is a line from the center, and this line is perpendicular to the chord. From center, perpendicular chord. And also look into the exam guide, which provides the exam guideline that provides the required theorems. So AM is equals to MB because of the line from center perpendicular to chord. So remember, the theorem said the line drawn from center perpendicular to chord bisects the chord. So that's why AM is therefore equals to MB. We can then, now that we have written that, let's just add this information here. So to say AM is equals to MB. So since AM is equals to MB, therefore that means AM is actually 2 times either AM or MB. So therefore the length of AB is the sum of AM plus the sum of what? MB. So what is AM? We learned that is 4. And we also learned that here MB is also equals to AM. So therefore 4 plus 4, that gives us 8 centimeters. So the length of AB is therefore 8 centimeters. So that is how we apply the theorem there. All right. So just watch the next video where I'll be looking at the converse theorem and theorem 1C, which is the perpendicular bisector of chord. So for now, please practice more activities related to the theorem just to master it. It is good that you do more of these activities daily to understand the fundamentals or things that are required of you to, yes, you see. So practice more questions and we shall meet again on the next video. Thank you so much. Hope you enjoyed.